Try to please understand. I was about to introduce this in my previous class, actually. This is a very difficult and depth topic. I'm just informing you this. Now, in this, what you can study here is basically we know this is a fixed axis. It won't rotate at all. If a body moves, it moves either in this direction or in this direction. In such a case, this is a simple operation which you will do. And this term is what we will call as pure translation. Now imagine that at this instant, at this instant, at this instant, this is your x-axis. Intentional written x naught to justify that it is at t is equal to 0. Intentionally written y naught to intentionally set it as 0. Right. Now, the axis also rotated. Axis also rotated. X, Y. Remember, this angle is theta. This is rotating. Right. Now, in respect to the same contest, if I do a derivation, what happens? I'm doing this, you need to differentiate this in a two-way method because this is also a variable. At that instant, it is r cap. Next instant, that r cap is oriented in a different direction. I think we are clear till this point. So therefore, no, velocity of A with respect to B. Here is a rotating observer. Here is a observer on the ground. So he noticed that their relation is like this. It is not only that now I will define this as an operator. It is an operator that converts inertial frame of reference to rotating frame of reference. You see that this is an operator. This is entirely an operator. Any doubts till this point? It's an information that I have to tell now. For example, I am here rotating along, when I'm fixed, glued to B, point B, and I'm been rotated with the angular velocity omega. Right. Right now, the linear velocity is r omega. You know already this. Here is an observer in the inertial frame. The velocity of B with respect to A till yesterday, day before yesterday, this is what we are discussing, r omega simply. Whenever I utter r omega, now please acknowledge me, what term did I utter? It is the velocity or the speed at that instant of P as observed by an observer on the ground in an inertial frame. Now, if I am B, then what is the picture? Go back. You have this relation, velocity of A with respect. That's what you have now. Velocity of A with respect to B is defined as, because you are in now rotation frame. Hello. Rotation frame, inertial frame, plus omega bar plus something. Now you want this, you want this. So therefore, this is equal to the ground or inertial frame minus this. Now I am taking this as velocity of A with respect to B as observed by the rotating frame is velocity of A with respect to B as observed by the ground frame minus omega bar cross RAB bar. which means if you observed that it has some r omega velocity, for this observer, you will notice r omega as one component and omega bar cross RAB as a component like this. Don't question me why it is in that direction. Simple. Omega bar thumb upwards. So I can take K cap. Anything towards me is K cap. Next, RAB. RAB. What is the direction of RAB? Simply I cap. With respect to B, the position of A is along I cap. At that instant, boss. So therefore, K cap cross I cap is K cap cross I cap is J cap normally, but there is a minus term here. Minus J cap. So therefore, it should be the direction here. See, my intention of discussing all that above stuff is to make sure that you know this. Lot of questions arrive from this part. 99% of the students will fail. 99%. So now I will post these notes also. నేను వెళ్ళిపోయేటప్పుడు your duty is to make sure that I post this in the group, both the video as well as this thing, right? Now consider the same example above B A. Who is B? B is an observer in the rotating frame. A is an object either in motion or rest with respect to ground, right? The same thing that I'm drawing here, whatever that I have uttered here, I'm replicating that over here. So what is that you observe in rotating frame is with respect to ground, and this is the conversion factor. Don't forget, this is the thumb rule. That is the thumb rule. What is the thumb rule? Dou by dou t of some function in rotating frame is dou by dou t of the same function in inertial frame minus omega bar cross dash. That is the general conversion rule, which I have already discussed at the beginning of our class. Now, what you want velocity of A with respect to B? Let that be VAB bar in rotational frame is VAB in inertial frame minus omega bar cross RAB. Yes, just now I have written there, here below. RAB, taking this as origin position of A. Right. Now we are writing this, just reversed this properly. You have any objection in moving from here to here? Any student in the class? Any student in the class? Do you have any objection in the process of shifting from here to here? Any doubts? Now you do area, please. I can write this in this way also, no? VA bar minus VB bar is nothing but d by dt of RA bar minus RB bar. This is VAB R plus omega bar cross RAB. Now you do this one differentiation with respect to time again. Already this is a differentiation term. I am doing this one more time. So which means this is all inertial term, which means this is all inertial term. Inertial term is with respect to ground. Now this differentiation part will contain two terms. And this differentiation part will contain three terms. Sir, till now everything is fine. Till now you taught us in English. All of a sudden your language changed to Malayalam. Till now we are comfortable. All of a sudden you have changed. Remember, I didn't change anything. Left side is in inertial frame. That differentiation. Okay, I'll ask you a question. X is the position, right? X is the position. Okay. Instantaneous velocity, dx by dt. Instantaneous acceleration, d square x by dt square. Fine. Why you have done all these things? Because the axis is not rotating, it's fixed. The problem here is the right side system is a rotating system. So whenever there is a rotating system, you have this conversion factor. Hello, this is the conversion factor. For every one differentiation, you will have two terms. Now tell me, if you are differentiating this, you will have two terms. If I am differentiating this, normally A cross B, normally itself there are two differentiation terms. Plus one differentiation of RAB contain two such terms like this. So totally how many terms? Five terms. I just want to add some points again, basic. I know some students are looking towards me very seriously. D by dt of A bar cross B bar is defined as dA bar by dt cross B bar plus A bar cross dB bar by dt. Now, will you agree that this differentiation contains two terms? Now, therefore, this differentiation actually should contain two terms. But dRAB bar by dt will contain how many terms? Two more terms. So, totally, this is one plus here there are two terms, three terms. So, three terms in this, two terms in this. I am not cheating you. For the understanding purpose, I have changed the colors. Can you see the change in the colors here? Boys and girls, can you please change? Can you please see the change in the colors here? The red color indicates the two terms which I have commented. The blue color represents the three terms which I have indicated to you. Now, please try to see that this particular term, are you rotating? Oh, yeah, fine. I'm differentiating this term, right? When I'm differentiating this term, d by dt of VAB rotating plus omega bar cross VAB bar. First term is done. When you are differentiating this, you should differentiate this also. So while I'm differentiating this, I got this term d dou by dou t of VAB rotation plus omega bar cross VAB bar. First point clear? Now next point, d omega bar by dt cross RAB bar plus omega bar cross VAB bar rotation plus I have straight away taken two terms here. Boys and girls. अरे यार डी आर ए बी बार बाई डी टी क्या लिखना है इधर अभी अभी लिखा हो ना मैंने डी आर ए बी बार बाई डी टी हियर ओनली आई हैव रिटन डी आर ए बी बाई डी टी हियर डी आर ए बी बाई डी टी is VAB rotation plus omega bar cross RAB. I have used one straight away here. That is how you got three terms. अरे यार this is and this term both are same. Both are same. So I have written this two times of this. And you know this you will call as acceleration of A with respect to B rotation frame. And d omega bar by dt already you know this is called alpha bar cross RAB plus omega bar cross AB bar. Now, please, let me rearrange everything properly. This is only inertial, but acceleration of A with respect to B is acceleration of B with respect to rotating frame, two times of this, next term. Now you multiply all the sides with mass of A. Don't forget you are observing A. You are observing A. Now mass of A, all that I have written, what I am going to do is, I will knock all these terms to this side is equal to the left side. Now what I am going to get is this is equal to MA bar plus all this nonsense stuff. Remember MA bar is actual real force as per Newton's second law. Why you are looking at me seriously? Mass times acceleration is the net force in an inertial frame. Newton's second law is strictly applicable in inertial frame. So this is the real force. All this nonsense, hello, all this nonsense is pseudo force. The super pseudo force contain three terms. Four terms. Already you know, when we are dealing problems related to Vinay, నేను మళ్ళీ అరగంట తర్వాత చేస్తాను నేను. Right. When, forget about this part. You already worked, no? I am a frame moving with an acceleration A and I am observing U, whose mass is M. Then M times minus A bar is pseudo force. So this is the linear pseudo force. This is the linear pseudo force. Minus of blah, 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 something you can see here. This is a new force, which is what we will call as Corolios force. Corolios force. Next, followed by this term. This you are already aware of. Alpha bar times R bar. That is called Euler force. Minus of this term is called, this is nothing but centripetal acceleration. But minus times is there. So it will become centrifugal force. So how many forces I have introduced now? 4. One is pseudo force linear. Next is Corolios force. Third is Euler force. Fourth is centrifugal force. That's all. I want to teach only this. Sir, how am I going to use this? I doubt you may not. Say, depth is high. Right. Now, for example, I am projecting this in this direction and it is rotating it like this. So what is the formula for F Corolius? Omega bar cross VABR. Corolius direction, omega bar cross V relative, and a minus sign to this. But you are rotating it like this, correct? Right hand grip rule, thumb upwards. So in which direction it is? In which direction? K cap direction. And this is in the positive Z direction. అంతేగా V relative is positive Z direction. మామూలుగా K cap cross J cap అంటే minus I cap. Minus of minus plus I cap. So this is the direction of Corolius force. So because of that damn direction, since you projected here, since it is traveling here, you see that it travels like this. Why? No one is actually moving. It is because of the pseudo force it is moving like this. Now you change the direction of the spin. Yeah, minus I cap. What else to discuss on this? So therefore, in that case, this is how it will travel. The seasons will form because of this. Actually, the cloud intention is to move towards the equator. Because of the rotation of the earth, they will move like this. Next. Right. So at the center, Corolius force, exactly at the center, Corolius force 0. Because when it is at the center, we relative we consider as 0. Suppose if earth is not rotating for a while, any object that is thrown from north, it will automatically reach O. Actually, it will just aimed some point at the equator, it will just move like this on the northern sphere. Because earth is rotating like this, because earth is rotating like this, it will move in this sense. So southern hemisphere, if Earth is not rotating, it would reach O like this. Because Earth is rotating, it will reach like this. In fact, this is responsible for your monsoons right now, which we are facing right now. Okay? Now you see here. Now you see here. You will see maximum deflection at the poles. Minimum deflection or zero deflection at the equator. Can you please tell me why? Almost omega bar cross V relative bar is zero. Now you can see. So if wind tends to move like this, the red color shows the deflection. If the wind tends to move like this, deflection is like this. Suppose if the wind tends to move like this, the deflection is like this. All these are due to the Corolios force. Right. Maximum I have covered. Only one problem which I felt to discuss with you. Please go through that. Now, please try this. See, in this, Anushka is nothing but our someone who is sitting A here. Earlier, it is B in our general exam. Right. Go through that. At the same, Anushka observes Virat to be moving at a speed root 10 meter per second and is a non-negative integer. At the same moment, the rate at which Anushka observes the distance between them is decreasing to be root m. What exactly is root m term? In fact, that is r omega term. That is r omega term. అరే ఇప్పుడు మనం చూసాం కదా ఇప్పుడే ఆల్రెడీ ఇప్పుడు ఈ అబ్జర్వర్కి టూ కాంపోనెంట్స్ ఉంటాయి. ఒకటి ఆర్ ఒమేగా ఉంటే ఒకటి మాడ్యులస్ ఆఫ్ ఒమేగా బార్ క్రాస్ ఆర్ రిలేటివ్ బార్. జస్ట్ నౌ వీ హావ్ సీన్. సో ఈ రిజల్టెంట్ వాడు రూట్ అని ఇచ్చాడు అండ్ ఈ కాంపోనెంట్ వాడు రూట్ అని ఇచ్చాడు. నెక్స్ట్, at the same moment, Anushka observed Virat's velocity perpendicular to the line joining them is root p. అన్నీ ఇచ్చేసాక నేను చేసేదే ఉంది. ఇప్పుడు వాడు ఏమంటాడు చెప్పనా? రూట్ ఎమ్ పర్పెండిక్యులర్ కాంపోనెంట్ రూట్ పి ఇది వచ్చేసి ఏమి ఇచ్చారు? రూట్ ఎన్. దట్స్ వాట్ దే హావ్ గివెన్. సో వాట్ ఐ నో ఇస్ m square squaring and adding and gives m plus p is equal to n. Pythagoras theorem. You require only one out of this. See, Anushka moves directly towards him with a speed 1 meter per second. You know what is that exactly? R omega, R relative omega is 1. R relative, R omega, R omega. Radius times omega is 1. Radius is 6 is what you mentioned. Omega is 1 by 6. R omega means, practically speaking, root m is equal to 1. So m is equal to 1. Done. You said that 12 meters away means, here, this distance is 12 meters. Radius is 6 meters. So this distance is, as per Pythagoras theorem, it will be 6 root 3 meters. Here, Pythagoras theorem, simple application. Right. Now, and this is nothing but, can you please help me? What is this? This is nothing but R relative. What is this component? You said P. Actually, what is root P? Actually, root P is nothing but omega R relative. Omega is 1 by 6. R relative 6 root 3. 6 cancel root 3. So simply P is equal to 3. Bhaiya P3 correct. M1 correct. इधर क्या हो रहा है? N is equal to M plus P. 3 plus 1, 4 correct. Done. You are going to face this question sometime either in this week or next coming weeks in the cumulative. Yes. I taught you this. These are some difficult questions. I don't find time to clear it right now. And just please confirm me, have you gone through this question? This one, 17. Go through the question, please. Go through the question, please. A rod is L-shaped and it is free to rotate in a horizontal plane about a vertical axis, that which passes through one end O. Sleeve of mass M can slide freely on a smooth arm of the rod. The sleeve is attached to a light spring of force constant K. Other end of the spring is tied to the bend at A. Tied. That's all. So, try to please understand, in rest situation, this is L naught. Without rotation, this distance is L naught. If there is no rotation, it is L naught. If there is rotation, what happens? Arey bhaiya, top view, you are rotating it like this. Bhaiya, this is the radius of my circle actually. By the way, when there is rotation, pseudo force is there. Centrifugal force, that is in this direction. It will have two components. One component along the length of this arm and the other is perpendicular. Remember, if this is the direction of G, all this is in XY plane. Don't feel that the rod is in vertical plane. The entire L shape is in horizontal plane. The axis is vertical. So in the process of rotation, the mr omega square stretches the spring. So finally, what will happen is mr omega square cos theta is equal to Ke. Correct, na? Otherwise, how you will have equilibrium sustained here? Now, m omega square, see, by the way, geometry says if this is r and this is theta, then r cos theta is nothing but L naught plus C. Geometry, trigonometry. So therefore, I have used that. So from this, I got the elongation. It's a very famous problem. Irido question also. It's an Irido question, basically. Next. Yeah, come on. This is also a very important question. But please go through the question, everyone. Small disk P is placed on an inclined plane, forming an inclined angle theta with the horizontal. Actually, this is related to friction only, but curvature is also required. So I have used this right now. Horizontal and important initial velocity V naught. Find how the velocity of the disk depends on the angle phi, which its velocity vector makes with the x-axis. X-axis. X-axis is shown already here. This is x-axis. X-axis. This is x-axis. And one more information given, mu is tan theta. So wherever I find mu cos theta, I can write sin theta. Now this is the curve, right? That is the curve. At an instant, this is the velocity vector. If this is the direction of tendency of motion, this is the direction of friction. Right. At this point, what happens? Now you have the component of the weight, mg sine theta. You have phi. If this is, see, please try to understand, if this is V, that V is the tangent actually at that point. Friction is exactly opposite to that. I just want to see force on the tangential direction. What are the different forces on the tangential direction? By already along x, there is a mg sine theta force. And it will have a component in this direction because you said this is a phi angle. So therefore, this is mg sine theta cos phi. Agreed? Done. That's what I have written here. Minus friction. Or you are moving mu n, mu mg cos theta. That is the tangential force, which I will write it as MAT. G sin theta times cos phi minus 1 is 80. Keep that as. Now we will try to understand what is happening along the x-axis. Along the x-axis, forces are mg sin theta minus friction component. Friction component, mu mg cos theta cos phi. Okay, I'm speaking about accelerations. So ax is g sin theta minus mu g cos theta cos phi. G sin theta into 1 minus cos phi. Clearly, you can notice one thing. This plus this is 0. See, the tangential acceleration and the x acceleration components will sum 0. Now I'll try to differentiate this, integrate this. If you are integrating acceleration, you'll get velocity. V plus Vx is some constant C. Don't forget, at a given instant, if this is V, this is V cos phi, which is called Vx. I've written that here. When t is equal to 0, there is a term. Initially, phi naught is pi by 2. You mentioned that in the question. If I use that, Vx becomes 0, V becomes V naught, C becomes V naught. So now you substitute that V naught plus V naught cos phi is C. So V is V naught by 1 plus cos. Very standard question. You're expected to get. Rest I have solved almost all. This is also one important model. Please go through the question. Figure shows the velocity and acceleration of a point-like body at the initial moment of its motion. The acceleration vector of the body remains constant. The minimum radius of curvature. Initial minimum radius of curvature undadu. I think radius of curvature concept you are well aware of. So now you treat this is a constant. You projected it like this. So I will treat this as a projectile now. In a projectile, at this point, radius of curvature is minimum. So at this point, what is going to be the velocity? U cos theta, G. In the place of G, you have A. In the place of U cos 60, you have some term there. You can see that. I have applied it. I got the least radius of curvature there. These are very important models. Just now, I'll post this in your notes. Okay? Right. That's all. So tomorrow you will have exam.